Alright, so MSM 111, tutorial 7. Binomial. Start from question 3. Actually, let's do question 4 instead, okay? It says write down the expansion of Alright, so what we need to first remember is n factorial means n minus 1, okay, n minus 3 and so on, so that we have maybe 4 factorial is the same as 4, n is 4 times 3 times 2 times 1, right? So this is the binomial. So how do we then go about these questions? The formulas that were given, we have a plus b to the power n being equals to a, or we can say n choose 0, a to the power n minus 0, b to the power 0 plus n1 a n minus 1 b minus 1 x like that, plus, remember it's a plus b to the power n. Next is a n minus 2 b2 plus a n minus 3 b3. Okay, plus there will be a point when we will reach a n. Now these particular factors all have this. Okay, so we have 1, 0, 1, 2, 3. The last one, this is not the last one though, n to the power r, then a, n minus r, b, r. Then it continues until you reach b to the power n. Okay, so that continues until you reach that far end, which is b to the power n. Now, when we're looking at these questions, we also have to note, so maybe I'll erase this part so that you see, same class, a, n choose r, a n minus r, b r, plus b to the power n. Okay. Right. So this is the formula for the binomial expansion. Alright, so we also have another general formula which we'll talk about later on. What did we say? N choose r is actually n factorial over n minus r. Okay, so this is the formula for n factorial, so n factorial, n choose r, n factorial over n minus 1 factorial, r factorial. Okay. Let's use this to solve some questions. Right, so you've been told write down the expansion of 2 plus, this is question 4. Or let's start from question 3. So question 3, we've been told a plus 5 to the power 5. Okay, a plus 5 to the power 5. This is, if a is given us, so a is given as 3 over 4, and b is given as 1 over 4. Okay, so a is 3 over 4 and b is 1. The question is, find the values as a fraction of the fourth term of the expansion. So we're looking for the fourth term. Okay, now we're going to expand this up to the fourth term, then we're going to look at the coefficient of the fourth term. So we have a plus b to the power 5 is equal to a, which is the power 5 plus 5, choose 1, a to the power 4, b plus 5, 2, a to the power 3, b2 plus 5, choose 3, b to the power 3 plus 5, choose 4. Okay, 5, choose 4. A to the power 1, b to the power 4 plus 5, choose 5. Choose a to the power 0, b to the power 5. Right. So we can use Pascal's triangle. Pascal's triangle tells us we have a plus 1, or let me say a plus b to the power 1. This is to the power 0. This is simply 1, right? So these that I'm writing here, I'm using Pascal's triangle. So this is 0, 1, 1, 2, 1. So using Pascal's triangle, what you simply do is you are going to say the first one is always 1. So a plus b to the power 0 is 1. Okay. A plus b to the power 2. So a plus b, the power 1 is actually a plus b. So that's 1, 1. Okay. So a plus b to the power 3 to the power 2. If you recall, a plus b to the power 2 is a squared plus 2ab plus b squared. But refer to the Pascal's triangle. Okay. So with reference to the Pascal's triangle, we can have 1, 1, 1, 1, 1, 2, 1, 1, 3, 2 plus 1 is 3, 1, 1, 1 plus 3 is 4, 3 plus 3, 6, 3 plus 1, 4, 1. Then we have 1, 5, 10, 10, 5, 1. So 1, 2, 3, 4, 5, 6. So already this is a plus b to the power 5. Okay. So a plus b to the power 5. The coefficients is the same as saying the coefficient of the first term is 1. The coefficient of the second term is 5. The coefficient of the third term is this. So by Pascal's triangle, what we're going to have is 5 choose 1 is actually 1 choose 1 is 1. 5 choose 0 is 1. So we have a to the power 5 plus 5 choose 1 is 5. Then we have 10, a3, b2 plus 10, a2, b3 plus 5, a, b4. Then the last one is, this is 1, so it's b to the power 5. Okay, the last one is b to the power 5. In short, let's find them. Okay, let's find them. 5 choose 1. 5 choose 1 is the same as 5 factorial over. Remember the general formula. Okay, so 5 minus 1 is 4 factorial, then 1 factorial. This is the same as 5 times 4 factorial over 4 factorial times 1. Okay, so this and this will cancel, so this is just 5. So this is the 5 we are seeing here. Okay, so 5 choose 1 is 5 from there. So that's how it goes to the values, okay? Maybe let's consider 5 choose 3. 5 choose 3, so 1, 2, 3. So 5 choose 3 is 5 factorial over 5 minus 3 is 2 factorial. Then we have 3 factorial. This is the same as 5 times. I end up the largest in the denominator. So we have 5 times 4 times 3 factorial over 2 factorial, 3 factorial. This and this will cancel. So we have 20 over 2, which is simply 10. Okay? So 5 choose 3 is 10. So this is the 10 you are seeing here. So 5 choose 3 is 10. So that's how it goes to that 10. Okay? 5 choose 4. 5 choose 4 will therefore be equals to 5 factorial over 5 minus 4 is 1 factorial, 4 factorial. So this is 5 times 4 factorial over 1 times 4 factorial. This and this will cancel, so the answer is 5. So this is the 5 that you are seeing here. Okay, so that's the 5 that you are seeing there. Apart from that, 5 choose 5 is 1. Okay, so the general principle is that n choose 0 is actually 1, and n choose n is also 1. So these are the two general principles. N choose 0 is 1, and n choose n is still 1. Okay, so basically speaking, this is the expansion that we have here. Okay, so now what we've been asked for is that given that a is equal to 3 over 4 and b is equal to 1 over 4, okay, find the fourth term. Find as a fraction the value of the fourth term. This is the question. Find the value as a fraction of the fourth term of the expansion. So the fourth term, we're going to count how many terms we have. So 1, 2, 3, 4. So that's the term that we are being asked for, okay? That's the term we're being asked for. Alright, so fourth term, 1, 2, 3, 4, so 10 a squared b to the power 3. Then we've been told that a is 3 over 4, b is 1 over 4. Okay, so yes, so we have 3 over 4, 1 over 4. This ends up being, we know that this can be reduced. This will be 2, this will be 5, so this is 15 over 8. So that's your answer, okay, 15 over 8. Others would have written it as 30 over 16. If you went directly, this would have been 30 over 16, but you know 2 can go into 30 15 times and can go into 16 8 times, so it still goes back to 15 over 8. Alright, so you can either go that route or the other route. Both of them will get you to the same answer. Okay, so that's how you solve such questions. That's how you solve such questions. Next up, question 4. says write down the expansions of 2 plus x, 2 plus x, 2 plus x to the power 4, and 2 minus x to the power 4. Okay, and 2 minus x to the power 4. Right, so then what? Part 2, so let's find those expansions first. So expanding this, we are going to have the first part. We can still use Pascal's triangle, okay? So 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. So these are the coefficients of the expansion, right? So these are the coefficients of the expansion by Pascal's triangle. Okay, so since we're dealing with these coefficients, what is the expansion for this? So we have 2 plus x to the power 4 is equals to 2 to the power 4 plus, the next one is going to be 2 to the power 3, then x, right? Now, before I even write that, what's the coefficient there? It's 4, then 2 to the power 3, x, plus, the next one is 6, the coefficient is 6, so I write 6, then 6 multiplied by 2 to the power 2, x to the power 2, plus the next one is 4, 2 x to the power 3, plus the next one, the last one is 1, there's a 1 here, which is thus x, so this is 2 to the power 0, x to the power 4. Okay, one thing you should also note is this. If you look at this expansion, you notice that these two here, the power of x tends to sum up to n, right? So whenever you're given an expansion, or whenever you're looking at a binomial expansion, if you have a plus b to the power n, okay, the first one, as we said, would be n to 0, a to the power n minus 0, b 0. Next one is n choose 1, a to the power n minus 1, b to the power 1. The other one is n choose 2, a to the power n minus 2, b2. Okay, if you look at this, the sum of the powers of a and b are always coming back to n. The powers of a and b are always coming back to n. So if you look at this, n plus n minus 0 is simply 0, n minus 1, n minus 2. So if you add n minus 0 plus 0 is 0, n minus 1 plus 1 is n. Sorry, this is n also. N minus 2 plus 2 is actually n. So in the same way, when you find the coefficients, remember here I can use this simultaneously. Okay, so I can use them simultaneously. So we're saying n to 0, alright, is simply 1. The standard is still here. N choose 1, n choose 0 is 1. So this is where the 1 is coming from. N choose 1 is simply n. Okay, so another one which you need to take note of is n choose 1 is always n. Okay, so those three are important to know. Okay. That having been said, let's look at how did maybe the 4 come up. This 4. So this is 1, 2, 3, 4. Okay. So since it's the 4th, we have n choose 3, which is in this case 4 choose 3. So what is 4 choose 3? 4 choose 3 is 4 factorial over 4 minus 3 is 1 factorial, 3 factorial. So this will end at 4 times 3, the largest is 3 factorial, 1 factorial, 3 factorial. So this and this will cancel, so the answer is 4. Okay, so this is where this 4 is coming from, right? So you can use Pascal's triangle, or you can still use this formula, and you still get back to the same answer, right? Alright, so let's find the final of this. So the final of this 2 to the power 4 is actually 16, okay? 2 to the power 3 we know is 8. 8 times 4 is 32, so plus 32x plus 2 to the power 4 is actually 2 to the power 2 is 4 times 6 is 24, so we have 24x squared plus 2 times 4, which is 8, x to the power 3 plus 2 to the power 0 is 1, so x to the power 4. Okay, so that is your expansion there. Next up, if I can write, so that is that in ascending powers of x. So notice that the powers of x are ascending, so we have 0, 1, 2, 3 up to 4. Okay, next up we have 2 minus x. That's the other expansion we are asked for. 2 minus x to the power 4. Okay, so this is not different from the other one. 2 minus x to the power 4 is not so different. The coefficients will remain the same. So we have the first one as 2 to the power 4. Okay, now we're going to simply make the x negative instead of positive, because these look almost exactly the same. The only difference is the x. Okay, so the x would be negative throughout. So this is going to be plus 4, 2 to the power 3, negative x instead, then plus 6, 2 to the power 2, negative x squared. Remember, I'm now replacing with negative x. Alright, plus 4, 2 negative x to the power 3. Plus 2 to the power 0, negative x to the power 4. Alright, then we have 2 to the power 4, it remains 16. This remains the same, it's going to be 32, but the sign is going to be negative 32x. 2 to the power 3 is 8 times 4, 32 times negative x is negative 32x. Okay, then 2 to the power 4, 2 is 4, so it's going to remain the same, but it's going to be 24. Okay, when you never square a negative number, it still remains positive. So it remains positive, it becomes positive. If it's negative, it becomes positive. The next number here is going to be 8, but the x is cubed, so instead of positive, we are going to have minus x cubed, because negative 1 to the power 3 is still negative 1. Alright, then plus x to the power 4. So these are the two that you have. Okay, so those are the two that you have. So how do we go about the next part of the question after that? Alright, so after this, now we've been asked to find, these are the two expansions in question. Right, so these are the two expansions. We have 2 plus x to the power 4 is this, and 2 minus x to the power 4 is given as this. Okay? Part 2. So I've expanded. Part 2 says, hence simplify 2 plus x to the power 4 plus 2 minus x to the power 4. Hence simplify. Okay? Hence simplify. So we've been taught to simplify 2 plus x. So we've been taught to simplify that. This is part 2 now. Okay, so for starters, we know that 2 to the power 2 plus x to the power 4 is this. So let's erase that. What you're going to have is simply so we're saying 2 plus x to the power 4 plus 2 minus x to the power 4 is equals to 16 plus 32x plus 24x squared plus 8x to the power 3 plus x to the power 4, everything plus the other one, which is open bracket 16 minus 32 so plus 16 minus 32x plus 24x squared minus 8x cubed plus x to the power 4. Okay. Alright, so I would have actually extended going all the way here, like this. I think it's visible. Alright, so if you are adding this to 16 plus 16 is 32. We have 32 minus 32 is 0, so this and this will cancel. We have 24x squared plus 24x squared, which is 48x squared. 8x cubed, these two cancel. Okay, so we have 32 plus 48x squared plus x to the power 4. Okay, so this is what we have as 2 plus x to the power 4 plus 2 minus x to the power 4. Right, so I've simplified, right? After simplifying, the next thing that we've been asked for is to find the exact value. So this is a part of application of the binomial, okay, expansions. So it's a bit of application. You've been told, let's find the exact value of 2 plus root of 3, the power 4 plus open 2 minus root of 3 to the power 4. Okay, so you've been asked to find the exact value of that expansion. 2 plus root of 3 to the power 4 plus 2 minus root of 3 to the power 4. Right. So if you consider these two, what you will notice is that this looks exactly like this. Alright, so this and this are exactly the same. So if this and this are exactly the same, 2 is 2, then what is x? Then x is actually root of 3. Because you see, x is root of 3. Don't consider the minus here, x is still root of 3. So meaning where there's x, I can put root of 3. Okay? So where there's x in this expansion, I'll put root of 3. So we're saying these two are exactly the same. Alright, so meaning that the expansion for this is actually 32 plus 48 root of 3 squared plus root of 3 to the power 4. Alright, now we know that root of 3 is like to the power. Okay, so we have 32 plus root of 3 is what? Root of 3 is 3. Root of 3 squared is 3, so 48 times 3, 144. So we have 144 plus root of 3 times root of 3 is 3. Then root of 3 times root of 3 is so this is actually 9. Okay? That is 9. If you want, you would have written this for the sake of someone. Let me just write the root of 3 part. Root of 3 can be written as root of 3 is the same as, we're saying root of 3 to the power 2. This is the same as 3 to the power 1 over 2. alright? But raise to the power 2. So this and this will cancel, so it's 3. Okay? Now what if it's raised to the power 4? So we'll have 3 to the power 1 over 2, the power 4. Okay? So now we have half times 4 is actually 2. 3 squared is 9. So this is where this 9 is coming from here. Okay, so this is where the 9 is coming from. That's where the 9 is coming from. Then lastly, so what is 32 plus 144 plus 9? This is equals to 185. So that's the exact value. Okay, so this is application of the binomial on the expansion. Okay, so the first thing that we were told is we needed to find the expansion of 2 plus x to the power 4 on that. We expanded them, we added them, we ended up having an expression like this one. Find the exact value of this, we had to compare the two. Okay, we had to compare the two and we ended up having the x is actually root of 3. Okay, from this x is root of 3. As you can see, x is root of 3, so there's a negative, it just ends up being a negative. End of that question. Let's go to the next question. Okay, so we now have question 5. Question 5, I did a similar question on question 5. We start with part 1. Determine the value of each of the following corrects to 5 significant figures using the binomial theory. So we have 0.98, okay, to the power 0.98 to the power 7. Alright, so 0.98 to the power 7. Now, how did they come up to 0.98? Okay, so for them to find 0.98, they must have subtracted something. Remember, the nearest whole number is 1. So let's find out what did they remove. So we're saying 1.00 minus 0.98. Okay, this is going to be 2, 0.0. So meaning for them to get to 0.98, they subtracted from 1, 0.02. Okay, for them to get to 0.98, they subtracted from 1, 0.02. Alright, so this is what they subtracted. Now that we know what they subtracted, we're using the binomial, so now that we know what they subtracted, we can rewrite this. This is the same as 1 minus 0.9, sorry, 0.02, okay, the power x, alright? So let's factor out the 2, so that we have 1 minus 2, then we have 0.01 power 7. So this is how it looks like. I'm writing it like that so that you understand the exact value that we are dealing with. Okay, so I need to make it look like something that you people are familiar with. Okay, I want to do something that you are familiar with. So now let's look at this as an expansion on its own. So let's assume this is actually 1 minus 2x. So I've just replaced 0.01 with an x, alright? So I've replaced 0.01 with an x, so what's the expansion of this? The expansion of this will be 1. Now we've been taught to find significant figures, so meaning the highest we can go is probably 3. Okay, so up to the term containing x to the power 3, because 0.01 raised to the power 3 is already beyond 5. Okay, so we have 1 to the power 7, okay, plus 7 choose 1, then we have 1 to the power 6, negative 2x to the power 1, plus 7 choose 2, 1 to the power 5, negative 2x to the power 2, plus 7 choose 3, 1 to the power 4, negative 2x to the power 3. Okay, so as I said, you notice that the powers of these coefficients actually end up being 7. Okay, so when you check, if you add these two, if you add 6 plus 1 is 7, 5 plus 2 is 7, 4 plus 3 is 7, so that the sum of the two powers ends up being n. N in this case is 7, right? So we can now have 1 plus 7 choose 1 is simply 7. Then 7 choose 1 is 7 times this is negative 14x, okay? Then the next part is we now need to know what is 7 choose 2. 7 choose 2, we'll solve it from here. 7 choose 2 is actually 7 factorial over 5 factorial, 2 factorial, which is the same as 7 times 6 times 5 factorial. I'm ending at the largest in the denominator, so 5 factorial, 2 factorial, this and this will cancel. So this is 2, 7 times 6, okay, let's just say 6 divided by 2 is 3. So the answer is 21. So 7 choose 2 is 21. Then 21 negative 2 to the power 2 is 4. So it's 21 times 4. Okay, so I'll just write 21 here. Then we have 4x squared. But basically we know that this is 84. Right, so this is 84. We'll write it later. 7 choose 3. What is 7 choose 3? So we now need to know what 7 choose 3 is. 7 choose 3 is 7 factorial over 7 minus 3 is 4. Okay, 7 minus 3 is 4. Factorial 3 factorial, so this is 7 times 5, 6 times 5 times 4 factorial over 4 factorial, 3 factorial. This and this will cancel. Now 3 factorial is 3 times 2, so which is 6. So 6, that 7 times 5 is 45. Okay? No, 7 times 5 is 35. Okay? So 7 times 5 is 35. So we have negative 2 to the power 3 is 8. So we'll say plus, negative plus, open brackets, 35, open brackets, this is negative 8 x to the power 3. Okay, so 1 minus 14 x plus 21 times 4 is 84 x squared, then 35 times 8, so 35, 8, 0, 4, 24, 280, so minus 280 x to the power 3. Okay, so that is the expansion that we have. Okay, so 1 minus 14x plus 84x squared minus 280x to the power 3. So that is the expansion for 1 minus 2x to the power 7. Okay, so up to the third term. Now I ended at 3 because I know that the number here is 0.01. If you raise it to the power 3, you actually end up having 6, okay, 6 significant figures, which is beyond the 5 we've been asked for. So let's find the exact value now. Okay, so if you notice, if you compare this one and this one, your x is actually 0.01, okay? If you compare this one and this one, your x is actually 0.01. Right, so erasing this part. Erasing that part, we have 1 minus 2, 0.01 to the power 7. So this is actually the same as this thing here, so it's 1 minus 14. Now, wherever there is x, as I said, if you compare the two, you notice that this is an exact expansion for this one. Okay, so x is actually, if you look at this, 1 minus 2x power 7 and 1 minus 2, 0.01 to the power 7. From this we're saying this is 1, this is 1, this is 2, this is 2, so x is actually equals to 0.01, okay? So in this expansion here, we're going to replace wherever there's x with 0.01, but if you find it difficult to deal with decimal, what you can do is you can rewrite this into a fraction. So this is actually x. How many decimal places do we have? We have 2, so 1 over 100, okay? So x is 1 over 100, so we're going to have a 1 minus 14, 0.01, okay, then we have plus 84, 0.01 squared, minus 280, 0.01 to the power 3. Okay. Basically what we have now is 1 minus 14 times this is 0.14. 0.01 is actually, the 0.01 to the power 2 is 0.0001. So this is the same as 84 plus 84 multiplied by 0.123. Okay, so this is what you get. Okay, so minus 280, 0.01 to the power 3 is the same as 0.0112345 okay? Alright, so that's how you work around those values. From here we have 1 minus 0.14 plus, this is going to be 0.00084, okay, we multiply this times this, so it's 0.0084. Now, basically speaking, the other way you can actually write this is, instead of, I'm going to have this as 84, okay? Because there is a 10 in this, there is a 10 in that. So here minus 0.000, then we're going to have 280, okay? So 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5. So that's what you'll get. Okay. So what is the value we're looking for? Remember, we're not using a calculator. So we are going to add what we can add and subtract what we can subtract. So we have 1.00884. So that's the positive part which you have. Okay, then the negative part we have minus 0.140280. Okay, so this is the negative part which you have. I've simply added this one and this one to get 1.00084. Okay, so 1.000. So this is supposed to be 1.0084. Yes. Okay, so 1.0084. Then we have this part as 0.14028. I added the negatives here, so the negative 0.14028, so 0.14028. So this is what we have. Okay, so the overall difference becomes 0. This is 7, 14. 14 minus 8 is 6. This is 5, 0. This we can say 1, 9, 10, 6, 8.0. So this ends up being 0.860560. Okay, 0.860560. That is basically your difference. Okay, so that is the difference which you have. Okay, so if you look at the question that we have, if you look at the question which we have, let's look at the difference which we have. Okay, so whenever you are dealing with such questions, and you find yourself in an exam, okay, so you're in an exam and you're not allowed to use a calculator, what do you do? If you're not allowed to use a calculator, what do you do? So what we're saying is that to find the value, which is the final value here, we simply replace. So 14 multiplied by this is simply 0.14. Okay, this is 0.00014. Okay, how did we get there? Let's assume you're using a fraction. Okay, let's use you're using a fraction. 84 1 over 100 to the power 2. Right, so this is 84. 100 to the power 2 is 10000, so which is basically 10,000. Okay, so which is basically 10,000. So we are now, it's like you're now saying 84 over 10,000, right? So 84 over 10,000 is going to be 0.0084. Okay, so this is what you are going to have. Right. So basically, this is, you consider the number of decimal places, so 0. So how many zeros do you need to add to this? So you have 1, 2, 3. So 1, 2, 3. So this is what you get 84. Okay, so this is why we have 3 zeros in between 84. So this is 0.000084. All right, so that's how you get to that. Okay, so remember that the first zero that you have is represented by the decimal. Okay, so the first zero that you have represents the decimal. Let's look at a similar question. Let's look at a similar question. So that's how we were getting to those values. In case you were wondering, the same way, it's the same thing that we did for the other one as well. The 0.01 to the power 3, okay, it's the same thing. So 0.01, this is like saying 100 to the power 3, okay, so it's 1. Okay, so this is basically 1 million, okay, so this is 1 million. Then we have 280 divided by 1 million, so you end up having 0.123, then you have 280, right? So that's how we find those values. Okay, then lastly, we said we needed the difference, okay? So to find the difference, we said the first thing is 1.0084, that's what we wrote there. I added the positive ones, okay? So the positive ones was 1 and 0.0084. Then from there, we also needed to add the negative ones. So adding the negative ones, you notice that you have, it's like saying 0.000280, okay? So this is 3, this is 6, okay? So it's like saying 0.000028, then plus 0.14. Okay, and this ends up being 0.14028. Okay, 0, but without the negative, because you're dealing with negative values. You're dealing with negative values. Alright, suffice to say, let's continue now. Okay. Let us continue from there. So the final answer which we get is going to be 86812. 86812. Okay, so that is your. Now we've been told to 5 significant figures, 2, 4, 5. So that's to 5 significant figures. Okay, so that ends that question. All right. Let's look at a different question now. Let's look at a different question. Let's look at a different question. Okay, so the next question says, determine the 60th term in the expansion of that. We need to determine the middle term. Okay, so this question is saying let's look at a similar question. Part 2. (1.003 to the power 5). Okay, so what's the first thing that we do? As we said, we want to know how do they get to this. So now this is beyond 1, meaning they must have added something to. So this is the same as 1 plus, they must have added 0.03 to 1. Okay, so 1.00 minus. So now here we are going to subtract the 1.003 minus 1. Okay, so 1.000. So we have 300.0. So meaning they must have added 0.003 to 1 in order for them to get 1.003. So that is how they got there. Okay, so what we do is we're saying this is the same as 1 plus 0.003 the power 5. Okay, 1 plus 0.003 to the power 5. You can factor out the 3 from here, so you have 3, 0.001 to the power 5. So this is what we have as our general expansion, and that is what we want. Okay, so that is what we have as our general expansion. That is what we have as our general expansion. Okay, so what do we do now? We're going to do a similar thing to what we are just from doing before. What we're going to do is we're going to say, I'm not going to finish this question, but I'm going to show you how to go about it. But we'll see how far we can go. Okay, so we're saying, when you're dealing with this question, we're going to replace 0.001 with an x, okay, so that we know the standard expansion. So this is 1 plus 3x to the power 5, right? Now, we've been told that we need to leave this to 5 significant figures. So what we are going to do is, when expanding this, we are going to have 1 plus 3x to the power 5. So the first one is going to be 1. Okay, so I can use the Pascal's triangle in this case. Okay, so just need the first 3. So by Pascal's triangle, we have 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 4, 3 plus 1, 4, 1, 1, 5. No. Okay, so 1, 2, 1, 1, 3, 3, 1, 1, yes, 4, 6, 3 plus 3, 6, 3 plus 3, this is 4, 1, then 1, 5, 10, 10, 5, 1. So this is what I'm looking for. So I'm looking for the expansion for the first 5 free terms, for 5 4 terms. Okay, so the first 4 terms, these are the coefficients. So we have 1 to the power 5 plus okay, so 1 plus 1 to the power 5 plus 1 to the power 4, then 3x plus. Now, instead of writing 1 here, we're going to refer to the Pascal's triangle and ask ourselves what's the coefficient in front is 5. So we have to have a 5 here, okay, like that. Then the next coefficient is 10, so we first write 10. Then from 10, we're going to say 1 to the power 3, then 3x, all right, 3x to the power 1 to the power 2. So let's write this nicely. Yes. Then plus 10 again. 1 to the power 2, 3x to the power 3. Okay, so if, as I said before, if you are going to add the powers of these two expansions, or the power of 1 and 3, it should always get you back to 1. So we have 1 plus 15x plus 3 to the power 2 is 9 times 10, that's 90, x squared plus 3 to the power, that's 27, so 270 x to the power 3. Okay, so that is the expansion which you have. I've used past first triangle to expand that. Alright, so 1 plus 3x to the power 5. This is what we have. Okay, so we're saying this is 5. Okay, so what we did is I simply picked the coefficients of a plus b to the power 5 from the past cos triangle, which is 1, 5, 10, 10, 5. Now I just need the first 4 terms because what I'm interested in is the term in x to the power 3. Okay, so the first coefficient is 1, so that's 1 to the power 5, plus the next one is 5, so I write 5, 1 to the power 4, then 3x, which is this part, to the power 1. If you add 4 plus 1 is 5, okay? So again here, if you add 3 plus 2 is 5, 1, 2 plus 3 is 5, okay? After that, the next thing we need is, we now need the value for that. Now, as I said before, if you look at these two, you will notice that they are exactly the same, okay? So they are exactly the same. Which one am I talking about? 1 plus 3, 0.001, okay? Let's say to the power 5, and 1 plus 3, 3x to the power 5. What do you note? From here you know that x is 0.001, okay? X is the same as 1 over 1000, so we use 1000 in this case. Okay, so what is the expansion now? The expansion in question is therefore equals to 1 plus 3, 0.001, the power 5 is equals to 1 plus 15, 1 over 1000, plus 90, 1 over 1000, squared plus 270, 1 over 1000, the power 3. Okay, so this is what we have. So if we're going to multiply, we have 1 plus 3, 0.001, the power 5 is equal to, the first value which we have is 1 plus 15 over 1000. The next value which we have plus 1000 to the power 2 is 1 million, so it's 90 over 1 million. Okay, then plus 270 over 1 billion. Okay, so alright, so that is what you have. So from this you have 1 plus. This is going to be 0 point. Remember 15 into that, so this is point, then 0, then 0015. So we have 015. Okay, so that is what we get. That is what we get. Then you are going to do a similar thing for the others. What is 90 over 1 million? Okay, so 90 over 1 million is the same as 0.123456. Okay, 270 over 1 billion is 0.1234 5, 6, 7, 8, 9. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Alright, so since we are adding, the final answer is going to be 1 point. Now, notice that all of them are of the same sign, okay? So let's write it. So I have to teach you how to not use a calculator, okay? So in case you are not using a calculator, this is the same as 1 point. The last one has got about 8. Yes, so it has got about 8. So we're going to write even this one about 9 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. The next one is 0.015. Okay. The next one is 0.01234. 1, 2, 3, 4, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 0. Then the last one is going to be 0, 1, 2, 3, 4, 5, 6. The number starts at 7. 1, 2, 3, 4, 5, 6, 7, 2, 0. Okay. So you are basically adding those 3. So we have 0, 0, 0, 0, 0, 0, we have 7. Okay, so here we've got 7. We have 2. Okay, let's use a black marker throughout. Okay, so we have 2, 0, 9, 0, 5, 1, 0.1. So 1.01509027, that is what you have. If you look at, asked to find 5 significant figures, so we have 1.12345. So your answer will end at 1509. Okay. So 1509, that's your answer. So we're saying basically 1 plus 3, 0. Let's say 1.003 to the power 5 is actually equal to 1.01509,245. Okay? So this is your answer that you have to 5 significant figures. Okay, so this is basically the application of the binomial part. Okay, so you may be asked to expand the number just like this, and this is how you're going to go about it. This is the end of the tutorial. Have a good day. And remember, for those who've not subscribed, subscribe to the channel so that you've got prompt notifications, okay? So subscribe to the channel, CZ. Alright, so have a good day.